In order for an equation to be true, both sides must evaluate out to the same number. So if we have this equation right here, we can say that it's a true statement because 2 plus 3 is equal to 5, and 5 is equal to 5. So it's the same number on both sides of the equation. Thus it's a true statement. When we talk about solving an equation, what this generally means is that we're trying to find a value of a variable that makes an equation into a true statement. So this equation right here, we would want to find the value of x that makes this the same value on both sides. X plus 3 and 7 are the same number. Well, without doing a whole lot of work on this, you might be able to see that, well, when x equals 4, that's, then we would get 4 plus 3 equals 7. Okay. Well, that's all fine and well, but how did you get that 4? Well, you got the 4 by saying what number plus 3 is equal to 7. And essentially what you want to do is you want to kind of undo this addition. And the way you undo addition is with subtraction. So really the operation that you kind of did here is, well, you did subtraction. You said x is equal to 7 minus 3, which is, of course, that 4 that we just got. So what we're doing is we're using an inverse operation. And what we end up seeing is that addition and subtraction are inverses. And multiplication and division are inverses. Alright, so we'll get into actually how to solve these. That was a little bit of a sneak peek here. But for the moment, we're just going to test to see if an equation is a true statement. So these values, when I say x equals 4, when I say x equals 4 is a solution to this equation, what I mean is that when I plug a 4 in for the value of x, it makes it into a true statement. So we call these things solutions. So if I'm asking, is x equal 4 a solution of this equation, well, all I have to do to check that is plug it in and see if it evaluates out to a true statement. Well, 2 times 4 minus 9, that's 8 minus 9 equals 18. Generally, when I'm checking to see if something is a true statement, I do a little question mark over the equals, because I'm not saying that it's equal, I'm checking to see if it's equal. So this would be, of course, -1 is equal to 18, and that's nonsense. So that means that x equals 4 is not a solution to this equation. If I was to try x equals 3, well, I could do the same thing. 2 times 3 minus 9 equals 18 with the question mark there. 6 minus 9 equals 18, and that one doesn't work either, because this is -3. So that means neither are solutions. Doing another couple examples here. The variable doesn't have to just be on one side of the equation like we saw there. The variable could be on both sides of the equation. Really the only important thing is that it's the same on both sides of the equation. So if I say x equals 2, and I'm checking to see if it satisfies this equation, we would do 2 squared plus 6 question mark equals 5 times 2. That's what, 4 plus 6 equals 5 times 2. Might as well do 5 times 2. That's 10. And that one's a true statement. So that means x equals 2 is a solution to that equation. Now, just because something is a solution doesn't mean that that's the only thing that's a solution. Let's try x equals 3. So let's go 3 squared plus 6 equals 5 times 3. That's 9 plus 6 equals 15. That one's a solution as well. So you can see both x equals 2 and x equals 3 are solutions to this equation. But, you could try something. I'll just try one additional number here. 4 squared plus 6 equals 5 times 4. Maybe there's something about this that makes everything a solution. Who knows? 16 plus 6 equals 20. That one's not a true statement. So that means that this is not a solution. Turns out this equation does have exactly 2 solutions, 2 and 3, but that's getting beyond this course. One thing you'll need to be careful with when checking to see if something is a solution is negatives. So in general, whenever you're plugging something in that's a negative value, just put it in parentheses to make sure everything works out correctly as far as the order of operations. So if I'm checking to see if 5 minus x is 5 minus x equals -3, checking to see if x equals negative 7 is a solution, well, I would write it like this. 4 minus parentheses negative 7 equals negative 3. So you can see the x, this is the x right here. That entire thing, so the parentheses and the negative 7 there. I'm checking to see if this is its solution. So I would do, well, 4 plus 7, because I would change subtraction to addition by doing it this way. And I'm checking to see if this is a solution. Well, 4 plus 7 is 11. 11 is not equal to negative 3. So no, x equals negative 7 is not a solution. And the same sort of thing works with even with fractions. However, with fractions, your best bet might be to pull out a calculator. Some of these would be kind of a pain in the butt to do. They'd be kind of a pain in the butt to do by hand because, I don't know, fractions are, well, they could be kind of a pain in the butt. So I'm going to type in 3 parentheses 2/3. So for my 2/3, you can see I put it in parentheses just like I did my negative value there. And for 2/3, I'm just doing 2 divided by 3. There's nothing special there. Then I'll go ahead and type in minus 5 parentheses 2/3. And you don't type in equals 3 when you're checking it on your calculator. You just evaluate one side of the equation. So I stop once I get to that equal sign. And I'll press equals, or enter on my keyboard. I get negative 1.3 repeating. So this says negative 1.3 repeating is equal to 2. And of course that's nonsense. So that means no. X equals 2/3 is not a solution. Don't be of the opinion, though, that just because something is a fraction that it can't be a solution. Sometimes things have to be fractions to be solutions. We'll see plenty of those examples in this class.